You guys, welcome back to my YouTube channel. We're still under mathematics, which is NCV level 4. We have given this question here. It's question 2. We have question 2. So this is mathematics. It was written in November. It's paper 1. So we've given here 2.1 says given f of x it's equal to 12x raised to the power of 3. This is a cubic. As you can see, you're dealing with what? With a cubic. Minus 28x squared minus 3x plus 7. It's a cubic because we have what here? Raised to the power of what? Of 3. That shows that there we are dealing with what? With a cubic. Alright, so it says prove that 2x minus 1 is a factor of f of x by applying what? The factor theorem. Long division is what? It's excluded. Check there, it's excluded. We have given here our marks allocation. There is 2 marks, as you can see there. All right, so how do we know that something is a factor? So if it's a factor, we have when we substitute, we'll treat this all the factor must be equals to what? To 0 if it's a factor. How are we going to test that? We have there 2x minus 1. This must be equals to what? To 0 if it's a factor. It is a proof that 2x minus 1 is a factor. If it's a factor, must be equals to 0. Then we can solve for x. If you solve for x, here you'll have x will be equals to what? You transpose 1 to this side. If you transpose there, we'll have what? Positive 1. Then you divide by the 2 there. You'll have positive 1 divided by 2. So you'll have 1 over 2. That is our x. So since its effect is equal to 0, we should take this 1 over 2 and substitute to the original equation. Where we see x, we replace it with what? With 1 over 2, and then we're supposed to get this to be equals to 0. Alright, let's check. We have there f of we want f of x there. We'll substitute it with what? With 1 over 2. Then we'll have this is equals to, we have 12. We have x. Where we see x, we replace it with 1 over 2. Then you replace this with 1 over 2. Obviously we have here cubed. You cubed this, it will be raised to the power of what? Of 3. Alright, minus 28. Alright, then you replace 1 over 2. We have here 1 over 2, isn't it? Then you square this, you minus this by 3 into 1 over 2, we together plus 7. If you punch this, it's supposed to give you 0, all of that. So we'll get this to be equal to what? To 0. If you have this 0, then this is what? It's a fact. That is how we identify. We can clearly state this is what? It's a fact. Now this is a fact actually. Then we can confidently say that can have 2x minus 1. It's a fact. Is a fact. Alright, so that is how you determine your factor there without using a long division. So we have there 2.2 here. We have our 2.2 says the expression you have given x cubed minus ax squared plus ax plus b is divisible by x plus 1 and x minus 3 and x plus m. So if given here, this is 3 marks, says 2.2.1 says determine the value of a and b. All right, how can you determine those? How can you determine those things there? How can you go about and determine those stuff there? All right, so we have this, want a and b. So if this is divisible by this, in other words, since it's divisible by this, in actual fact, these are what they're telling you, that these are factors. If these are factors of this expression, that means all of these factors must be equal to what? To 0 when you apply here. What I'm trying to say, we have given the x plus what? 1 there. This must be equals to 0 if it is divisible. It's actual like a factor. Also, x minus 3 must be equals to 0. Likewise, also that fact must be equals to that. Likewise, just did it as two unknown, but we'll see how we go about that. So let's start by doing these two, the one we should know them. We can say, okay, we let these to be equals to that. We have this, so you can see x. Okay, you take that one. This will be equals to -1. We have -1, so you can substitute this -1 here to into the equation. Where you see x, you replace that. Or you together there, you replace it. Why we do those? Why we do that is because now we know that we replace this. We know that it's a factor, isn't it? So since it's a factor, you come and you replace, or you substitute that. We'll have -1 raised to the power of 3 minus a, where you see x, you replace with -1, isn't it? Then you square this plus a, we have a there, we see a, so we have a, where we see x, we substitute -1 like that. Then we have b plus b, we don't know the value of b. This must be equals to 0 if it's clearly it's a fact when you substitute this. So when you punch this, obviously, because here is raised to the power of 3, it's an odd. If you take your calculate, this will also give you what? Will obtain -1. Here you will obtain your -1. Then you come again there, you do your thing. We have here minus, you multiply. Okay, this will be what? Positive when you square that. So this will be negative a. Then we have this positive a multiplied by -1. There will be negative a, as you can see. Then we're left with b. We'll have plus b. This must be equals to 0. This must be equals to 0. Then here you do math. We have a also here, as you can see there, that is a and a. So this will be what? -2. Here we have what? We have a, or you can take that a to the other side. Okay, this will be simply -1 minus 2a, this plus b. This must be equals to 0. So I can take It's up to you. I will take this a minus 1 to the other side. If I take that to the other side, I'll be left with minus 2a plus b. This will be positive 1. Then I can call this my equation. This will be my equation 1. All right. Equation 1. This is my equation 1. So since I have equation 1, what can I use? I will use this one again. I'll just say x, take this to the other side, will be equals to positive 3. We have positive 3. Then we take this and substitute to the original equation again. You understand? We'll substitute what? 3 to the original equation. So as we substitute there, we have b 3 raised to the power of 3 minus we have a, then we multiply this by what? By positive 3, then plus we have here what? B, or we have again plus a. Here I don't forget to square since we have the square there. So multiply this by positive 3, then plus b. This must be equal to 0. We together, so this is 27 minus this 3 raised to the power of 2 is 9. So multiply by a. This will be what? 9a. Then you multiply that guy there. Are we together? We'll multiply that. Is what? A multiplied by 3. We'll have there plus 3a plus b. All this must be equals to 0. We have that to be equals to what? To 0. All right. So these are like terms, as you can see. Okay, here I have 27. Here I still have that minus 9a plus that must give us what? There. What should be? We are taking away that. We'll have with what? We're left with our 6, isn't it? There. So we'll have positive now. This will be positive 6a. We have b. We have b there. So plus b. This must be equals to 0. All right, I can take this 27 to the other side here. I will left with I'll be left with 6a plus b. This must be equals to negative 27. Then this, I can call this my equation 2. This is my equation 2. So we have to solve this problem now. I have 2 equations. So can see minus equation 1 minus it with equation 2. What does I mean by saying that? Equation 1 minus by equation 2, I mean this you minus with this equation here. Check here, equation 1, here it's equation 1, isn't it? You subtract the left hand side, you subtract with the left hand side, the right hand side, you subtract with the right hand side. All right, let me show you. We have this is our left hand side, you subtract it with the left hand side. What I'm trying to say, the right hand side, you subtract it with what? With the right hand side. Here it's equation 1. Okay, I have them. Equation 1, the left hand side of the equation 1 is 2 negative 2a plus b, as you can see there. All right, what about of subtract by equation 2? The left hand side of this must be subtracted by the left hand side of that, will be minus what? Minus 6a plus b. So be careful, since you have two terms, you put the brackets, you are subtracting if you have a, or we put parentheses since you have two terms. All right, this must be equals to what? Now we're going to the, this was the left hand side, now going to the right hand side. As you can see, we have 1, equation 1, as you can see, substitute by equation 2 again. Here we have negative 27, isn't it? So here we'll minus negative 27 here. All right, this is what we have. You have minus 2a plus b, then you distribute this will be negative 6a minus b, this must be equals to, then you minus d, you subtract 1, as you know that will be 28, isn't it? But you're subtracting that guy to the what is this here? It's positive, so you have to do your subtraction. You will subtract, okay, in this side. Okay, let me check this side first. Here, this and this will give us what? All right, oh, that is what we have there. All right, so if we check here, this is minus 1, or it's let me check here. It should be okay. This must be okay. I'm just checking that we've taken this code. Oh, this was negative. All right, so this here is became positive to this side here when it's transposed, which is correct. This is our equation 1. Then we subtract with the equation 2, which is minus 27. All right, so we'll subtract now. Since we're subtracting, remember already we had the negative here. Here, if you can check, let me do this. I don't have to confuse. Obviously we have 1, isn't it? We minus, isn't it? We said we subtract the left hand side with the left hand side. We have positive 1, isn't it? Here we have negative. Already this is negative. We subtract, also we include the negative. This will be negative 27, by the way. So obvious, this will be, when you multiply, this will be positive. So we'll have 1 plus 27 will be affected there. So that is why we'll result having what? A positive. Are we together then? So we have here negative 2a and negative 6a there. So that is what we have there. Those negative Here we have this guy and this guy is supposed to cancel. We have minus b and positive b, those will cancel. Here we have a negative, this will be negative 8, if you can check there, minus 6 there. This is a negative, let me check to my equation. We have here, then we have subtract, this will become minus, then that became minus, so this and this will be negative 8a. This must be equal, we'll add there, you'll have 28. All right. We have positive 28. That is what I have here. All right, so we have to divide. If I can check here, did I do my things correctly? It's just that I'm not feeling well, guys. I'm sick, so I want to see that I did not make mistake. But this is simply just, you can even use using substitution. Yes, this is good here. This must be okay, must be negative, positive, right? Let me check. We have minus 9 there, plus 3 will be negative 6. Okay, this is negative here. I can see from here. Here it's my mistake here. You see, those will give us what? Negative 6. So this must be negative. So this is actually what? A negative. If this is a negative, that means here I will have positive. Here, then since I have positive, minus a minus 2a plus this must give us what will be 4 here. All right, so no problem. This will be we are subtracting those. We are adding minus 2 plus 6a will be positive 4a. This will be equals to 28 here. All right, so you divide both sides by 4, divide both sides by 4, so our a will be equals to what? There you punch there on your calculator, you will obtain 7. That will be equals to 7. All right, we have the value of a now. All right, it's good. So we have equation 2. We can have that. We have our equation 2. We have a. We can substitute to any equation so that we can obtain what? B. Which one will be simpler? I want to obtain the value of this guy. All right, we have this. We can find the value of b. You can choose any between these equations there. All right, I can take, if I take a and substitute it here, I can use this equation there, equation 1. Can use an equation there, like minus 2a plus b. This must be equals to 1. Then minus 2, I substitute 7 here, plus b. This must be equals to positive 1. Multiplying this, we know this will be minus 14 plus b. This must be equals to 7. So b, the value of b will be equals to what? 7 plus 14. then b will be equals to what? Oh, this is 1, so this is 1. I don't know, today I feel like I'm tired. Actually, yeah, this flu, I made some mistakes here, a lot of mistakes. Actually today, this is 1, as you can see. That means this will be 15. This will be 15. All right, it's the value of a and b. We have the value of a and b. They said we should determine this a and b there. This was supposed to be only 2 minutes. It's just that, yeah, hence determine the value of m. This will simply, it is the easiest. You want the value of m, this guy. Remember also it's a fact, if you want the value of m, we have determined the value of, we have now the value of a and the value of b. You simply substitute back here, then you compare, you distribute this, and then you compare with this one, you distribute this, you distribute until it becomes a cubic. Then you compare. How? Let me show you. We want the value of that m. Now we should compare. Okay, we have 2.2 point. We have to compare there with the original one. We have x cubed. All right, then here we have again minus. Remember now it's what? It's a. It's a here. Where I see a, I replace with a. We have calculated the value of a. I replace with a. The value of b have calculated. Where? Here it's our value of a. Here it's 7. Value of b is 15. So you substitute back to that original equation that we, or expression. That expression. All right. So you substitute a. We found that a is 7, isn't it? We have 7. Here we'll have x squared plus, we're supposed to be ax. A is 7. We have our x plus b, but our b is 15. Simply compare. This must be equals to the other expression. Remember now, these are factors. We have factorized this. You compare this with your factors. Remember these are the factors that we have there. The one that we are given, x plus 1 into, is divisible, isn't it? X minus 3, and we have also x plus m. These are the factors. So that means if I fuel this, it must give me this thing. But now I have to compare. What I'm trying to say, you simply distribute these things. You distribute until you have something which has a cubic. Then you compare. How? I will distribute it because it will take long. Just distribute it on your own. You know how to distribute. You just fuel. After you have to distribute all of that thing. After you have distributed, you will obtain something. You will obtain x cubed. We have distributed every. After you've distributed, just distribute everything there. You distribute. You should obtain something like minus 3x squared plus x squared minus 3x plus x squared m minus 3x m plus xm and minus 3m. This is a whole. You compare the last with the last. We have, what is the last number here on this equation? The last. Compare the last with the last. What I'm trying to say here is the last. You see the last here. Remember, this is a y-intercept. Regardless, that will be y-intercept. Doesn't matter how long it is, this thing, as long it starts with, as long as the highest value here, the exponent or the degree, we have x raised to the power of what? Of 3. You see these two, as long the first one, you see they correspond, doesn't matter. Don't worry about all of these, which is inside. Compare the last with the last. The last we have 15. You compare it with the last one, which is minus 3m. That is how you find this question. 15 must be equals to what? To negative 3m. The last must be equal. Those are y-intercepts. That means will be the, if you say this is the same, that means the y-intercept and that thing will be, remember it's a c. The last value is supposed to be c, isn't it? Of the cubic. You remember the expression of a cubic. It's what is d, something like that. If I'm not mistaken here. Yeah, we have x. This is d. That means this also, this is the of this expression. Do not worry about how many terms or how many values you have in the middle. Just correspond those. That is how you'll find this. You have 15. Then I'll divide by minus 3 both sides. Then this and this will cancel. Or left with m. Divide by that will be negative. Obviously we have our negative 5. We have our negative 5. M will be equals to minus 5. We to get, this is what we have there. We have the value of what? Of m. So this question contains, it will continue, it continue. We should have something here. All right. So we have this. Hope you can see this. I've correct this now. All right. I have this. We have that says we have 2.3 here. Says given the following set of order pairs of f, we have given these coordinates. As you can see, we have the x value. Remember, this is an x value. The other one is a what? Y value. These are coordinates. How coordinates stay? We have minus x, minus 3 plus 5 minus 2 into 5, not plus, sorry, minus 2 into 5, 0 into 7, 2 into 9. Those is x and y coordinate. Okay, they say 2.3.1 route f prime. This is an inverse as the set of order. You want the inverse of this. Inverse means just you switch around, you swipe, you switch. I mean, that meaning if you have, you switch around, you understand? You're switching around the coordinate, you're switching. If we have something like this, if we have x and y coordinates in inverse, you are switching now. You will switch. That means will be y and x. This is an inverse. This is our inverse. That is what f prime 1, like f minus 1, like that. There, this is an inverse. You switch the order. So you simply switch all of these here. You switch. How do you switch? We want let's switch. You have this, you simply switch, will be 5 into minus 3. Simply switch, those are inverse, minus 2. You switch, you simply switch, be 7 0 9 2. That is how you switch. This our investing there. You switch. All right, you just do that. We have 2.2, 2.3. We have 2.3.2. Says state whether the inverse. This means the inverse it's a function or non-function. Obvious, the inverse is a non-function. You must know that. Of this will be a non-function. We discussed this using our vertical line test. Yeah, you must use your vertical line test. So it says write down the x-intercept. The x-intercept of what? Of the inverse. Okay. Write down the x-intercept of an inverse. What comes on your mind when you're talking about the phase of an inverse? You don't focus, we are no longer focusing here. We are focusing on this. It's an inverse. Here it's our coordinate for now of an inverse. Write down the x-intercept. What comes in my mind at the x-intercept? At the x-intercept, y must be equals to what? To 0. You check the coordinates where y is 0. That is our x-intercept here. You see, our y here is 0. 7 into 0. So that is where we'll have our use. Do not forget maths. This is a maths. Remember maths at the y-intercept. Right. X is equals to what? To 0. At the x-intercept, y is equal to 0. Do not forget those principles. So you check on your inverse. You see here, y is what? Your coordinate is 0. That means at x-intercept, we know that y is 0. So what is that value of x? The x-intercept, we know that it's when x is equals to 7. As you can see there, we took it. All right, so we have 2.3.4. It says write down the domain of this. What is the domain? We're talking about the values of x, but you must take a note. You want the domains of this. We are still here. We are not here. Remember, this is an f of x. It's f only. We are talking about f-1 there. We are focusing on this set here, on this coordinates that we have formulated here. So we know that we have 5. Our x, where it starts, means the graph starts here, where the value of x starts, and then it ends where? Here at 9. It means that is our domain. If you have a graph, for example, here it's your graph. Yeah, your graph, it goes and then it ends somewhere here. Let me just indicate that it's ending with a dot. It's ending. Remember, arrows shows that it contains, or open dot means that it contains, but this means that it's closed. But anyway, this is a topic of another day. The topic of another day. So let's say I want, here we have 4, here I have 7. What will be the domain? The domain, the graph starts here, the value of x, it starts at 4 and then it ends where? At 7. That means our domain will be between where our x value there will be what? Will be greater than 4. Remember, when you go to this side, it's in between. X is greater than or equals to 4 and less than or equals to what? To 7. Or you can say X is an element from, let's use the close bracket, from 4 up to 7. I'm making an example there. All right. So what about this? Here our inverse, it's 5 and then it ends where? At 9, as you can see. So our 2.3.4 is clearly that our, you can see this is an element, x is an element from where? From start from 5. Our lowest x coordinate there will start from 5 up until where? At 9. We have our 9 there. Sorry about that alarm. So we end there. You can write this. Some can some can use interval notation. You can say this is from 5. You can say x is greater than or equals to 5, but x is less than or equals to 9. You can use this format. It's up to you. Also, this is correct. So this is what we have typically in this video. So thank you for watching. Do not forget to subscribe. Do not forget to subscribe to my YouTube channel. Click the notification also. Click the notification button so that you'll be notified whenever I post a new video. Stay tuned. Feel free to like and comment and share this to your fellow classmates. And then I apologize for making some mistakes. I'm a little bit I have a flu now. I'm not okay actually, but all the best guys there.